Assalamualaikum and good morning. My name is Mohamed Azrai bin Idris, a student of PSM1, which study on computational fluid dynamics CFD simulation of wind loading and its impact to Haji Mohamed Yassin Mosque. So this is my title of my PSM. My supervisor is Dr. Fatimah Binti Mohamed Yusop of Faculty of Engineering Technology at University Tun Hussein on Malaysia. Okay, let's proceed to my presentation for PSM1. This is my content title, which first we start with introduction, which is background of study. So for the background of study, Malaysia is positioned near the equator and it experiences several sorts of monsoon seasons. And the variations in wind flow patterns are usually influenced by this monsoon, according to the Malaysian meteorology. So the wind load is used to refer to any pressure or forces that wind exerts on a building or structure. So according to Mendes P et al. P and friends, 2018, wind loads exerted on a building are not steady but dynamic and highly fluctuating. The fluctuating pressure could bring severe damage to building other than the wind force itself. So according to Ho, that he studied the effect of surrounding on wind loads on flat building, which they considered several cases with different types of immediate surroundings and concluded that increases in the surrounding, that means wind pressure acting on the building decreased, while unsteady pressure is increased. So Verma also studied with wind tunnel tests being very expensive and time consuming. So computational fluid CFD, computational fluid dynamics simulation has become a good alternative. Before that, another approach to analyze the wind is wind tunnel testing that has been used as an experimental tool to observe wind-induced behavior of a solid project. Okay, next is my problem statement in the study, which I choose Haji Mohamed Yassin Mosque because it is a new structure and I want to study the wind load of the building area and predict the impact of the wind load to the building. So the high wind pressures can collapse the doors and windows can rip off the roofing and roof decking and destroy the gables and walls. This happened at Sultan Zainal Abidin Stadium at Gong Badak, Kuala Terengganu, where the design orientation of the building did not consider as the effect of repeatable load acting on the building at certain direction and speed. At some point could lead to structural damage of the building. Besides that, the topographical and condition of where the building situated have not been critically identified, and geometry of the building that is not considering the condition of the topography. The Airflow Science Corporation has made numerous comparisons between the CFD modeling, physical modeling, and field testing. The result indicates the same accuracy at the velocities and the pressures. CFD also can predict what design changes most crucial to enhance the performance. It allowed the researcher to perform a graphic and visualize the wind load and determine the critical point. According to Yassin and friends, the application of CFD for practical wind engineering problem has received a lot of research attention over the last 3 decades and has made a major progress due to the advancements of computer technology. Continue to my objective for this project. The objective is to investigate the wind environment around Haji Mohamed Yassin Mosque and its load. The second one is to simulate the wind load impact to Haji Mohamed Yassin Mosque. And the last one is to analyze the wind load of Haji Mohamed Yassin Mosque from simulation result. Okay, so next we go to my scope of study. The first one is to investigation of the wind load behavior surrounding the Haji Mohamed Yassin Mosque. Then I will take the physical measurement at the mosque, which is the wind velocity or the dimension of the building to construct a 3D model before the simulation process. Okay, next I will present about a literature review. Literature review is the study that I've been researched before about this project, CFD. So I divide into, which is the wind load study on high-rise building and on low-rise building, because the mosque Haji Mohamed Yassin Mosque is considered as the low-rise building. For the high-rise building, Mendes has been researched that wind action are not horizontal. It generates lateral on the building and is not continuous to the height of building. Okay, so the it rises with height of the building because of the speed. It with differs with height as the obstacles on the ground decreases its speed due. So therefore, while analyzing a building, one should take care the wind forces acting horizontally on different heights of story. The pressure of the wind far up from the ground on structure will be different to the pressure applied by wind at point on the structure known as free stream static pressure. Okay, so the static pressure of falling wind and proportion of variance of force per unit area at a point on building to design wind pressure is called pressure coefficient. It depends on building, location, shape, and whether in the wind loads bring inward or outward pressures. Okay, so next is the octagonal building, where SK Verma has made a CFD simulation on the wind load has been done, and it consists of three elements, which is the simulation of atmospheric boundary layer flow, the validation of atmospheric boundary layer flow simulation, and the detail of meshing of the geometry of experimental. Okay, next, the CFD approach in 4 high-rise building. Yassin, Azrai, and Binti has researched that one of the major advantages of computer-based method of wind tunnels and field elevation is modeling flexibility, which is CFD. Okay, so on the computer, the inflow characteristic and model geometry can be modified easily, and a range of effects can be studied which would otherwise be expensive and time-consuming with conventional approach. For doing CFD wind analysis, 2 models are defined in ANSYS workbench. First one is a cubic shape for the building, which has its actual dimensions, and the second one is the proper cubic tunnel which the model builds locates in it. The wind tunnel should be big enough to order to have an easy flow to wind to get the proper results. Afterwards, the direction of the wind flow has been determined in CFD space. Since wind pressure exerted on the structure depends on the speed of the wind, the equation has been used for calculating the wind profile of the model. So as you can see, this is the equation 1, where the U is a wind speed and Y is height coordinate, and ABL is atmospheric boundary layer friction velocity, and K is for Kármán constant. Okay, next we will proceed to the wind load study on the category 2, which is a low rise building. Okay, so the Wang and friends has stated that the low rise building are generally not damaged due to structural vibration because of their high stiffness and low height, which is different from tall building. The evidence shows that the failure of the low rise building usually starts from the local failure of the envelope. So it is very important to study how to prevent the failure of the envelope for the wind resistance of low rise building. So the Truputa and Refudin has made an experiment of this wind load against the roof configuration of low rise building. According to the research, wind load information for 9 different models is presented in this paper. Non-dimensional pressure coefficient was experimentally obtained and used to identify the best roof configuration amongst the 9 models. The section was found to be the worst for the flat roof. And Wang also has made an experiment for the wind loading on the rise building in China due to high strong wind pressure and typhoon to study the turbulence, the characteristic of the near ground wind field, and wind effects on the full scale high-rise gable roof buildings. And next, the CFD approach for the low rise building. Okay, from the Fengza, since 2019 has made an CFD simulation to investigate the wind flow around the gable roof low rise building with different geometries. According to the experiment, it shows that the accuracy of simulation result highly relies on a wide range of simulation parameters which are imputed by CFD users. Okay, so the Binti and Louis also found that the CFD simulations by using Aran's equation with proper turbulence model are in good agreement with the wind tunnel results. Azrai and Bresowa carried out an aerodynamic mitigation study of wind-induced lift force on low-rise building using KNE, and RSM turbulent models, and the mitigation failure including the solid parapets and circular edge inclined edges and equal edges. The other research for CFD approach on the low-rise building will be made by Kim, that using wind tunnel testing of CFD techniques to provide the basis of traditional cut and dry approach for the design of parapets located at the roof edges on the low-rise building. In this approach, several parapets with different properties or height are investigated, and the one that yields the best performance, reducing high sections, is identified. Okay, for the next presentation, I will present a methodology, okay, which I start with objective one, okay, to investigate the wind environment around the mosque and its loop. Okay, I will start with problem statement and the site selection, which I have been selected and I've been presented about her objective and literature review. Okay, for the physical measurement, I will create a plan layout by measure the physical dimension and the wind velocity. Okay, it is important because I will use it as data for the next objective, which is a 3D modeling. Okay, for in 3D modeling, I will develop a model, 3D model, into the SolidWorks. Okay, so because the NCs needs 3D modeling from SolidWorks to run a simulation. So start with 3D modeling. My objectives 2 is started also along it with conduct with the simulation, which is to simulate the wind load impact to Haji Mohamed Yassin Mosque. Okay, so the NCs will run simulation, and for this project I will run to produce the result of pressure distribution at the building structure. Simulation need to be run until it success. Okay, so if the result is success, I will going for the objective 3, which is grid adaptation. If not, I will going back to the physical measurement, which I will take another measurement. Maybe the data is incorrect or error. Okay, how to determine the result is success or not? Okay, the result is in approximation method, so it's not experimental. It going to the nearest value. So in grid adaptation, if the result is yes, in grid adaptation, I will change the number of mesh to produce a values of result until it fails. So in grid adaptation also we can get a value of result according to the number of the mesh. So that's when the analysis will start. So this is the overall overview of my methodology for this project. Okay, next is how is this project impact to sustainable development. Okay, I have divided to the 3, which is a society, environment, economy. For the society, it provide society with software intelligence engineers, which we have knowledge about this software, and we can provide a safety solution to the society, to the building users. For the environment, we provide the building protection by using simulation, and the economy, of course, by using a physical experiment. For the data can be expensive, so by using this simulation, we can make the cost less than other experiment. Okay, so next we're going to my Gantt chart PSM. This is the progress during my works for PSM1, which is total for 14 weeks. Start with objective finding, data gathering, problem setting, idea generation, proposing supervisors, and proposal writing, problem submission. So for the whole PSM, the general research is always proceed for the through the 11 weeks, and this chapter 1 that I do start at week 4 until chapter 3 ended with week 13. So the report submission will be on the week 14. Next is my reference. Okay, so this reference is going to be from I take from the journal and also from the webs, because a journal is easy to find the research from the journal can be found at the website, and the journal is very helpful, and many journal based of CFD can be found about the high-rise building, low-rise building, also about the traffic. So that will be the end of my slides. First of all, I would like to say thank you to the panel which spend your time to hear my slide presentation, and I will looking forward for any comment or from the panel for the next meeting. So thank you, and Assalamualaikum warahmatullahi wabarakatuh.